Earlier this week, a boiling hot spring linked to an intrusion of magma appeared inside a house in an area completely absent of any similar geothermal features, filling it with steam. This occurred in the same area which across the last 10 months has seen another boiling hot spring suddenly appear beneath a second house, alongside the appearance of 5 patches of unusually warm ground, and 2 patches of steaming ground. All of these newly formed features were deemed to be volcanic in origin, being powered by very hot rising magmatic gases. And this occurred within Indonesia's portion of the island of Borneo, which itself has not been the site of a single volcanic eruption in more than 250,000 years. After all, I checked for signs of ground deformation and found none, and the reason for that is because, as it turns out, this magma was not actually new. Instead, this heat originated from a body of magma at 14 Pleistocene volcano km depth which has likely existed for many tens of thousands of years, possibly even hundreds of thousands of years. Although we do not know exactly how old this cooling body of magma is, we have a good idea on an upper bound in terms of age. At the approximate location shown on screen is what is likely to have been a largely basaltic andesite volcanic field at one point that has since almost completely eroded away beyond easy recognition. A combination of lava rocks and pyroclastic rocks, albeit primarily ash deposits from this unnamed Middle Pleistocene volcanic field, were dated, being determined to be between 400,000 and 500,000 years old. So, could a hypothetically 400,000-year-old body of magma at that depth still be cooling and thus degassing because it somehow hasn't fully solidified yet? Actually, yes, but only if this involved a truly massive intrusive body of magma, in other words a batholith. Batholiths at the depth of the known body of magma fully cool from the outwards in at a rate of about 1 cm every year. Thus, a body of magma would need to be at least a 8 km wide sphere for our hypothetical to be true, which isn't that too far outside the realm but possibility. However, it is seemingly more likely, at least in my opinion, that the body of magma causing is still a batholith but far younger, perhaps only being 100,000 years old. Okay, we've established that degassing from this deep and large body of magma is powering these hot springs and fumaroles which just appeared. So, why did geothermal features only appear now if the magma had truly existed for tens of thousands to hundreds of thousands of years? The answer is a thick underlying claystone magma, gas model rock unit which acted as an anticline which this entire time had been trapping the gas released from the underlying batholith.